Hey everyone, this is Nadeem and welcome to my YouTube channel. Today we will discuss about the phasor and phase difference. So the first one is the phase. Let's consider that sinusoidal wave which is formed by the moving coil inside the external magnetic field in the generator. So I mean that this is the phase diagram for the alternating current or the alternating voltage. So here this sinusoidal wave describe that alternating voltage or alternating current at each and every degree. So here this complete one cycle consists of about 360 degrees. At 0 degree we have the electromotive force is 0, the EMF is 0 at 1 degree. So let's say this is the 1 degree, 2 degree, 3 degree, 4 degree, 5 degree, and up to degree 90. Okay, this is actually the 90. A maximum electromotive force will be present, and after that 90 degree that electromotive force will be decreasing per degree. Okay, and if it reach 180 degree, then it again becomes 0, and after 180 degree at each and every increasement, the single increasement in the phase mean that if it become 181, their amplitude will be increasing. Their amplitude will be increasing in the opposite direction. So here this will be increasing, and for each degree it is increasing. And if we plot that large number of data points, okay, up to here, this is about 270 degree, mean that between 180 and 270 we have 90 degrees. So for each degree we have the alternating voltage, and that is increasing in the opposite direction. And above 270, if we go to 360, that will be decreasing. Okay, but in opposite direction, here its sign will be the negative, and we have discussed this in previous lectures in more detail. So here the phase mean that for each degree the increase in amplitude of the alternating quantity from this mean position, we call that as a phase. Okay, so this is actually a phase diagram. In phase diagram we have one complete cycle. In that one complete cycle we have 360 degrees, and for each degree we have the amplitude for the alternating voltage. So that each degree which have different magnitude of the alternating quantity, and that amplitude may be different in sign. So therefore for each degree that alternating quantity, the association of the change in the alternating quantity for each and every degree is described by the phase. Okay, phasor is actually the combination of the phase and vector. If we put the vector concept in the phase, we call that as a phasor. So here it will consist of the vector. Here we have that same vector. So this vector having magnitude is equal to the maximum amplitude of the wave. Okay, so this is that vector. And now we have the coordinate system. So in coordinate system, okay, we have we convert the whole, we cut the whole cycle into 4 parts. So this is the first, second, third and fourth part. Okay, so if we start from the 0 degree, here we will reach the 90 degree, then 180 degree, then to 70 degree, and then again we will come to 360 degree. Okay, so we have that same case here. Okay, so this is the 0 degree, we have we increasing 30 degree. Okay, so then it become 30, 60, 90, and by each increase in the 30 degree we will reach again here. Okay, so let's consider a torch here. So let's say this is the torch and the light is coming from that torch, and here we have the vector. So in this case the light come from this torch. Okay, this is the direction, and similarly here we have the direction is also from left to right, and here the direction of this the light from this torch is also from left to right. So here the angle is 0, so for that case the amplitude here is 0. Okay, so if we change the direction up to 30 degree, the direction of this this vector up to 30 degree, then the direction of the light from the torch is from left to right. Okay, and the direction of this is this vector is now making 30 angle with that light. Okay, so here from this top it will make some shadow here. Okay, so it will make this shadow, and now from we have that 30 degree. Okay, so from that we combine that shadow. Okay, so this will be the amplitude at 30 degree. So now at 60 degree we have that, and if we combine this, okay, then at 60 degree we will have that value. Okay, we will have this amplitude, and for 90 degree, okay, the shadow will be this. Okay, the shadow will be the shadow will be this, and here the amplitude will be at 90 is this. Okay, now after this 90, if we going towards 180, okay, the light is from this side and the shadow will be this. Okay, so the shadow will be this, and here at 220 we will have this amplitude. Okay, and at 150 the shadow will be this. Okay, and here the amplitude is this. Again at 180 the shadow, there will be no shadow. Okay, so therefore it is 0, and here at 210 this shadow will be formed. Okay, so this line here at 210, this amplitude is now in opposite direction from the mean position. Okay, and this is the amplitude, and now at 240 this will be the shadow and the amplitude become this. Similarly for 270 this will be the maximum in opposite direction. After that 300, okay, it will be again decrease, and at 330 this shadow will be formed. Okay, and at 0 this will become again 0. Okay, so here due to the motion of the vector which have the magnitude equal to the maximum amplitude, so here this vector is changing its angle. So by changing each degree of its angle, their shadow will be formed here. Okay, so if we plot that shadow for each increasement in the degree, we will again take that same graph. Okay, so that same sinusoidal wave we can plot by using this vector. So therefore we call that as a phasor. So this is actually the phase. Okay, so this phase can be made by the vector. So therefore this concept of a representation of this phase in the graphical form, we call that as a phasor. Okay, so here we have that same scenario. We have this vector, and here the amplitude of this vector is equal to the amplitude of this wave, and for each position, so now this is the position, here it will make the shadow and this will be the amplitude. Okay, so if this come here, okay, if it come here, the shadow will now be this, okay, and here it will make this amplitude, and for each it will make that. Okay, so this was about the phasor. Phasor is actually the graphical representation of the phase. And now before going to phase difference, we have to cover the concept of the cos theta and sin theta. As we know that if we have the vector, okay, let's say this is the vector, and we know from the resolution of the vector, this vector having this the projection, the y component of this vector is ay, okay, this component is in y direction and this is in a x direction, so this is the y component of this vector, this is the x component of this vector, and here in the y component we have ay, okay, this is ay is the y component of this a vector, which is equal to a sin theta, and in x axis we have a x vector which is equal to a cos of theta. It means that in y axis we will have the sine value, and in x axis we have the cos cos value, cos theta. Okay, so let's apply this the cos theta here on this diagram. Okay, so here we know from here that when the phase, when we move when the vector is in x direction, okay, then its cos will be maximum and their sine will be 0, because in x axis we have the cos theta and the sine theta is 0. Here the sine theta is in y axis, and in y axis we have the cos theta is 0, so we have to use that same concept here. So at cos 0, when the that vector is present in this positive x direction, so here we have the angle is equal to 0, so cos 0 is equal to 1, that is the positive axis. Now for cos 90, so cos is actually associated with the x axis, so for the y axis the cos value is 0, so therefore cos 90 is equal to 0. Similarly, in this case we have the cos value, okay, so this is the x-axis, but here now this is present in the negative x-axis, so therefore cos 180 is equal to -1 and the negative x-axis. So at 270 the cos is equal to 0, because the cos is associated with the x-axis, and here this is the value, this 270 is actually present on the y-axis, so therefore its value is 0, and similarly for 360 the cos value is 1. Okay, so if we plot these all values, so we will get this graph. Okay, so this is the maximum value, this is the +1 is the maximum value, and here this -1 is the minimum value. So at cos 0 we have the maximum value, at cos 90 we have this 0 value, at cos 180 we have the maximum value in opposite sign, so this is the -1. At cos 270 we have this again 0, at cos 360 we have maximum value, so this is that maximum value. So this sort of the graph is formed by the cos function, the cos theta. Okay, so now we have to apply the sine theta on this, so sine 0 is equal to 0. Why? This is because the sine theta is only associated with the y-axis, and here this 0 is on the x-axis. So on the x-axis we have the sine is 0, so therefore cos 0 is equal to sine 0 is equal to 0, because this is on the positive x-axis, and sine 90 is equal to 1 here. So here the sine 90 is equal to 1, because the here on the y-axis we have the sine value, and this is the positive y-axis. Similarly at sine 180, the value the value is 0, okay, because this is the x-axis and the sine is only associated with the y-axis. And similarly at 270 we have the sine value is -1, because this is the minus y-axis. And here again at sine 30 the value will at sine 360 the value will be 0, because this is the x-axis, and the sine value is only associated with the y-axis. So here this will be 0. So if we plot this sine wave, so this sine graph, so at sine 0 at 0 it gives us the 0 value. So here is that. At 90 it gives us the maximum value. At 180 it gives us again the 0 value. At 270 it give us the negative value in the negative, so in this side. So here that is -1, and at sine 360 we have again the 0 value. So from here we conclude that this is actually the cos this is actually the cos wave, okay, cos theta, and this is actually associated with the sine theta. So therefore we call this wave as a sinusoidal wave, okay. So here we have this, so here we have that sine theta, sine wave. So therefore we call this as a sinusoidal waveform, okay. So now this was the other concept of that phase. So this is that phase but with in more detail, okay. Now if we see here that this cos theta is actually here it is here it will become 0, okay, and here it is 0. So here the 0 of this cos theta is here, and here the 0 of this sine theta is here, okay. So its 0 position is leading the 0 position of this sine theta. So therefore we can say that the cos theta cos function, so the cos wave or the cos theta here lead, okay, so it lead the sine theta, and the other word we can say that sine theta lag the cos theta, okay. So lag mean that it is behind, so sine theta is behind the cos theta, okay, and here cos theta is exceed the sine theta. Here this is at 0 position before that sine theta, okay. So here is the difference between the phases, okay. So when it is in 0 position, okay, when this cos theta is in 0, so let's say here when it is in maximum, then this cos theta, if in maximum, this sine theta is in 0 position, okay. So if it is 90, if this cos theta is 0, okay, then it become maximum, and when that is maximum, this becomes 0, okay. So there is the difference between these phases. So that here is the difference between these phases, so therefore we call that as a phase difference. So here in this case phase difference is equal to 90 degree. Okay, so the cos theta is leading the sin theta with 90 degree. At the other word, we can say that the sin theta is lagging behind the cos theta with the 90 degree. So from here we also cover the concept of the phase difference. So we have these one, two, three, four waves. Okay, so if we draw a line here at this line, at this specific position, this wave have the maximum value on the negative axis, so it also have the maximum value on the negative axis, it also have the maximum value on the negative axis, and it also have the negative value on the negative maximum value on the negative axis. Okay, so similarly if we consider here this line, okay, so in this line this wave have maximum value, this have maximum value, this has maximum value, this has maximum value. So the phase of these all waves are same, so there is no phase difference here. Okay, so in this case this line the first vector the first phase having negative value, okay, negative maximum value, and here at this second phase have zero value, this third phase have again the zero value, this fourth phase have the maximum value, okay, and this also have the maximum value. So from here we conclude that these waves, okay, these phases are there is some phase difference present between these phases. Okay, now in this case up to here, so here is the phase, okay, this is the phase, and now here at this position if we draw the line here, okay, so at this position this red line have maximum value, this red phase have the maximum value, and this blue phase have the minimum value. So here is the phase difference, and that phase difference is 90. Okay, that phase difference is 90. Similarly we have that same scenario, we have that red phase, okay, and we have this blue phase, and this is actually that difference okay, this is actually that difference, one is this and the other one is this, so here is that phase difference, and in this case it is 90 degree. Okay, the same condition present here. Okay, so if we plot the phasor diagram for this phase difference, so for the first vector, okay, for this blue phase, for this blue wave, sinusoidal wave, we have this vector, okay, and the magnitude of this vector is equal to the amplitude of this phase. Okay, and similarly we have this phase and its amplitude, maximum amplitude, is equal to the magnitude of this red color vector. Okay, and these two phase, so here is the phase difference is 90, so therefore these vectors are making 90 degree. Okay, so if we add them, so this will be the resultant. Okay, by adding them with the head to tail rule, it will give us this resultant. Now here see, here is that if this vector here at this position, this vector, the blue colored vector, have the 0 value, and this red color vector had the maximum value. Okay, so one had the 0, the other one has the maximum value, and when it this become maximum, okay, so if it attain this position, then this vector will become in this position, so this red will become 0 when this become maximum. Okay, so here is the phase difference between this. Okay, so we have discussed about the generator here. So this phase is actually come from the generator. In generator we have the moving coil, and that moving coil is present in between the two poles of the permanent magnet, and due to change in magnetic field, and EMF is induced, and due to that this sort of line is produced. So how these two phases are produced? So here this one phase or this one sinusoidal wave is produced by that phenomena. So how these two phases are produced? So for that we have that same coil, okay, but here this coil, here in that case we have one coil, but here we have two coils. One is this horizontal and the other one is this vertical. Okay, so in this case, if we provide the external magnetic field, it's north pole of the here in this diagram, this is the north, okay, and this is the south pole. Okay, so the magnetic field lines are passing here. So when the magnetic flux is maximum, so here in this vertical coil, the magnetic flux is maximum, the EMF will be maximum. So at the same scenario, we have this horizontal coil. In that same at that same time, the flux in this horizontal coil will be 0, their EMF will be 0. It means that when the EMF induced in one coil is maximum, in the other coil that EMF will be 0. So therefore, so due to that phenomena, here is the phase difference is occur in that alternating quantities. So now what will happen if we provide that phase difference to a load? Okay, the load may be resistor, that may be inductor, that may be capacitor. So in resistor we have the two things passing through that. One is the voltage, which is the source for the current, and the other one is the current. So both are the alternating quantities. So here in the resistor, the phase difference between the current and voltage is 0. Okay, in inductor the voltage, in inductor the voltage lead the current. Okay, so here is the phase difference, and that is 90 degree. Similarly in capacitor, here this current is leading, and that voltage is lagging. Okay, so here voltage lag behind the current. Okay, and in this case no leading or lagging of the voltage and current, both are having the same voltage, and alternating current have same phase. Okay, so there is no phase difference. So between these two, in these two loads we have the phase difference. So this was the explanation about the phase difference. So now you may hear about the phases. So if we have three phases, mean that if we have three coils and that are present at 180 degree with each other, and we have the one, this is the north pole and this is the south pole, and the magnetic field lines are passing through here. So here in this case the EMF induced in one coil will be different from the EMF induced in the second coil and in the third coil, because each coil have in us making a specific angle with the external magnetic field. So due to which the magnetic flux will have a specific value, due to which due to that magnetic flux, the change in magnetic flux, the EMF will be induced, and that EMF will have different values. So therefore these different wave like shape will be formed. Okay, so in this case we have this one phase, this is the other phase, and this is the other phase. And here just like this arrangement of the coil, these phase also have here we have about how much difference. This is the 90, this is the 210, and the other one is 350. Okay, here is about 120 difference. Okay, 120 degree difference in the phases of these three phases. Okay, so how to form the to draw the phasor for these three phases? So the phasor diagram for that is this. So here the amplitude of the one, so here the vector, for the first the vector is this, for the second the vector is this, for the third the vector is that. Okay, so this is actually the projection. Okay, here the magnitude of the vectors are the same, but their projection are different, because at different they are leading and lagging at different angle. So therefore here the points are different. Okay, so this was about the three phase system. Now I am going to recap all these. So we have this generator, which is three-phase generator, and here we have three coils, and due to electromagnetic induction the EMF will be induced, and that EMF will have three phases. Okay, so from this one we have this red color wire, from this one we have this yellow color, and from this one we have that what we can say, from that black color. Okay, so if we combine these we have three phases. Okay, and you may see in the transmission lines we have three lines. Okay, and that come from the powerhouse towards your town. Okay, so we have the three lines. One is with this blue color, the other one, sorry, one is this blue color, the other one is this yellow color, and the other one is this red color, and we have the three phases. So for this this load, which is actually the AC, let's say this is actually the AC motor, this is actually the AC motor, and for AC motor we require three phases. Okay, so that three phases is come from here. Okay, one from this, other one from this, and other one from that. And if we, so here one is connected with this coil. So the first one, let's say the red one, is connected with this coil. This yellow one is connected with this coil, and that blue one is connected with this coil. Okay, so here in this case when the alternating current is provided to this, due to change here due to the current, magnetic field will be induced, and that rotor will be so here the magnetic field will be produced. Similarly, the magnetic field will be produced from this, the magnetic field will be produced from that this. Okay, and that magnetic field will be making 120 angle. Okay, here in the center. So therefore here therefore we say that in the AC motor we have the magnetic field is actually moving with the synchronous speed. So that synchronous speed is come from these alternating three-phase alternating current. So that three-phase alternating current produces the magnetic field, and the magnitude and direction of that magnetic field is also changing. So therefore the magnetic field is actually rotating, okay, at the center toward this rotor. So therefore their rotation we call as a synchronous speed. So that due to the synchronous speed of the changing magnetic field, this rotor inside this AC motor is rotating, okay. So here that magnitude is also different, a different position. And we have discussed, I think, about this AC motors, okay. So now for this bulb in our house, we required not three phases, only two phases, okay. So one is from this coil, which is this yellow, and the other one is that neutral, okay. So we need that two only. This load do not require the three phases, it required the two phase, okay. And that two phase is come in this way. So this is that two phase generator, and this is that three phase generator, okay. So this was the in-depth intuition of the phasor and the phase difference. And in phase difference we have these two concepts come into picture. One is the two phase generator, and the other one is this three phase, okay. And here when this two phases are passes through this these loads, it will behave different, okay. So this was today lecture, and I think you pick all these points, and that's all from my side, and that's it guys. Thanks for watching.